Hi everybody. What we're going to be doing in this video here is working on reading a meter stick, reading a triple beam balance, and working on reading graduated cylinders and calculating water displacement. In this first example here, I have a picture of a meter stick. What I want you to do at this time is read this meter stick to the best of your ability and put the right answer in the proper space for this video. The correct answer comes out to be 4.31, 4.32 centimeters, or 4.33 centimeters. The reason it comes out to be 4.31, 4.32, or 4.33 centimeters is because we know that the answer has a 4 in it. We know it goes past the 4. That's guaranteed. So that's why we have the 4 centimeters in there. We know that the measurement goes past the 0.3 centimeters. That's why it's in every single one of them. The last decimal place, remember, is your guesstimate. It's where you think the best guess is. The mark is showing it's really close down to the 0.3, it's real close to that 0.3 line. So it's under halfway. So 4.34, 4.35, 4.36 would be out. And it's not over halfway, so it can't be over that. So we know it has to be under halfway, or real close to halfway. In this case, 4.31, 4.32, and 4.33 give you that little bit of a range where somebody might say it's a little closer to the 0.3, some might say it's slightly farther from it. You get a range in there because it comes down to a guesstimation. It's an uncertain number. So that's how we get that answer. Now we're going to look at mass. When we're measuring with mass, we're looking at the triple beam balance in class, or another type of scale. But in this case, it's a triple beam. Remember, mass is going to be measured with the units grams. Length was measured using centimeters. So at this time, try to read this triple beam balance example and decide what the measurement would be. When you're reading over this, we know that there's a 400. We know that there's a 10 gram. So the 400 and the 10, we got those. You then have to read the 1 gram beam. The smallest beam there, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Those are your 1 gram beams. And they're going to be read the same way you would read a meter stick. So you find this to be about 5.9, let's say 1 would be one of the answers. So you get a choice here of 5.91. After you figure out what that 1 gram beam is, you add all the masses together. So the 400 plus the 10 plus the 4.91 grams equals 415.91. Now the reason we're saying 415.91 is on that 1 gram beam. The 400 and the 10 gram beam are just what they are. We know them to be exact. But this 1 gram beam is where it gives everybody difficulties. We know that that 5 is part of the answer. That 5 grams is part of the answer. It's guaranteed. The mark is past that. We know that the mark is slightly past that 0.9 grams there, based on what we see. It's slightly past it. Then at the last little decimal place there, it's going to be a guesstimate. It's going to be some form of guesstimation where you could have an answer of 450 or 5.91 grams there. You could have 5.92 grams, which gives you 415.92. And you could have 5.93 grams, which gives you 415.93 grams. Any one of those answers would be correct. You have to pick one. But because that mark is so far down close, it's probably going to be between 0.91 and 0.93. So now we're going on to the volume of a cube. This one should be one of the easiest ones for you because you've worked with this since probably back in 6th grade or maybe even elementary school, working with calculating the volume of cubical objects. At this time, please try to go through and calculate the volume of this cube. Remember, volume of a cube equals length times width times height. For this, the volume would be 8 meters times 5 meters times 5 meters. Pay attention to the units. We work with centimeters a lot, but you can still see meters. And your answer then would come out to 200 meters cubed, because meters times meters times meters. Now we're going to be reading the volume of a liquid. And when we read the volume of a liquid, we're looking at a graduated cylinder. So please take a moment and try to read this. So when we're looking here, we're going to read from the bottom of the meniscus, or the bottom of the bubble. And the bottom of the bubble right now goes right through that line. We have to decide what that line is. Up here is the top of the bubble. We're not going to read from it. That's why it's in red. We're not reading from the top of the bubble. That's the top of the meniscus. We're reading from the bottom of the meniscus. When you're reading it here, the answer comes out to be 24.0 milliliters, because that line, every graduation or every tick mark, every line goes up by 1. So 20, 21, 22, 23, 24. Now it's 24.0 because your answer needs a decimal place. A little cheat way to do this would be, if the line is 24, the next line is 25. Ask yourself, what's between 24 and 25? 24.5. If you have to say, or you can say 24.5, and that's your go-to answer there, and it has a decimal place, that means your answer most likely has a decimal place. Yes, you could have had an answer of 23.9 or 24.1 just because of some playroom here. But looking at this graduated cylinder, it looks to be pretty much dead on that line. So that's why I'm going with 24.0 milliliters. Could you have said 24.1? Yes. Could you have said 23.9? Yes. But those should be visibly above or below the line. So now the last type of problem here would be working with graduated cylinders and water displacement. Remember, water displacement we're going to use to find the volume of solid objects that we can't do length times width times height for. In this case, we have a fish. It's kind of hard to measure the length, the width, and the height of a fish, but you can drop it into water. And remember, the amount of that the water rises, however much it goes up by, that's the volume of the object in the water. So what we see is we calculate the volume of the object, or in this case the volume of the fish, using final volume minus initial volume. This volume on the left is going to be our initial volume, VI, at 32.0 milliliters. And the reason it's going to be 32.0 milliliters is because each one of these goes up by 2. And the reason it's our initial is there's nothing in there except the water. So each one goes up by 1s, each tick mark. Each one of these tick mark goes up by 1s. And then because of that, you have decimal places in your answer, because in between 32 and 33 is 32.5. So you can have a decimal place. It again looks at the bottom of the meniscus, looks to be pretty well dead on there. So we're going to say 32.0 milliliters. Over on the right here is going to be your VF, and that's going to be 38.0 milliliters. Then you're going to go through and you're going to do the calculations. VO equals VF minus VI. VO equals 38.0 milliliters minus 32.0 milliliters. And the volume of the object has a volume of 6.0 milliliters, or the volume of the fish. That volume of the O, that O means object. In this case, it would be the fish. Hopefully this helps you understand each one of these a little bit better before your quiz coming up here. If you have any questions, please feel free to contact me. I hope you have a good day, everybody. Bye-bye.